Now, if your events are dependent, then the probability of both occurring, the probability of A and B is probability of A times the probability of B given that A happened. It's important, if your events are dependent, to take into account the fact that you're only worried about the case where B happened after P, B given A. So the case where B happened after A. Okay, so this is a slightly different formula. Whereas if they were independent, they had probability of A times probability of B. But now that they're dependent, we have to specify that it's B given A. So a department store is holding a drawing to give free shopping sprees to 2 lucky customers. There are 14 customers who have entered the drawing. 4 live in the town of Gaston, 6 live in Pike, and 4 live in Wells. In the drawing, the first customer will be selected at random, then the second customer will be selected at random from the remaining customers. What is the probability that both customers selected are Wells residents? So real quick, how many of the customers were from Wells? Well, there were 4 out of the 14 customers. So I just put the problem back in. The probability of somebody being from Wells was 4 out of 14. The probability of somebody being from Wells, given that we already pulled one from Wells, is 4 out of 14 times 3 out of 14. 3 out of 14 is after you've already pulled one Wells resident out of the 14. So there's only 13 customers left and 3 Wells residents. So the probability when you multiply it 4 over 14 times 3 over 13 is going to be 12 over some really big number, which you probably can leave as a fraction unless you're told to change it to a decimal.